Hey, welcome! Hello everyone! I'm an artist who likes to do things as freely as possible, because to me this is fundamental. I learned this through traditional programs like Blender, 2DX Max, Maya, and others. The sequence of steps for better efficiency is occurred through greater simplicity and practicality as possible. The creative part of the artist can be explored in the best possible way, through the freedom to create and develop his works in an easy and intuitive way. Therefore, the artist becomes more productive and provides a better quality of work. And, of course, in addition to being able to solve the problems in a faster and without complications. So, the best question to ask is, what could be done to make 3D code better and start getting the attention it deserves? I think that for that to happen there could be a reflection of something that would make the program simpler, more practical, easier, and more intuitive to use. In my opinion, 3D code could start thinking about the system of a single mesh. This type of system most of the artists of the world already know, and they are accustomed from the beginning of the learning until they become professionals. This is already traditional in 3D world, unless some alien technology comes along and from there things change. A single mesh would provide own benefits to 3D code, as well as important and essential implementation for the program. The first good thing would be the unification of the whole system in favor of this single mesh. This means that our artists would no longer have confusions in relation to rooms, and that all rooms would be available with all of their features and tools aimed for this mesh in real time. I will try to demonstrate with Blender how a single mesh system could only bring benefits for 3D code to become better. I have no intention of teaching Blender or any kind of workflow, but rather demonstrate what an artist would be able to do with a single mesh system and thus perform any kind of task freely. I chose Blender because it features practically all the similarities of rooms that exist in 3D code and many other things that deserve to be highlighted. As you can see, we have this sphere. This sphere is composed mostly of quads, but in its top and base made of triangles. Here I can already show a big and important differential. The user can work with quads, triangles, and angles that are polygons with more than 4 edges in the same structure of the mesh. In 3D code, any mesh within surface mode becomes triangular and does not allow UVs in the mesh. This means that any mesh that is ported into the sculpture room, its structure will tend to triangles, and if the mesh has UVs, it will be lost. The operation of 3D code is different from all other types of programs. One type of mesh in the retuple room with the UVs and another mesh with a different structure in the sculpture room. The direct communication between these two types of mesh is made only of conform and snap functionalities, otherwise there is no interactive connection between the two meshes. This means that if you use modeling tools like split, extrude, bevel, and the others in the mesh that is in the retuple room, it will not change the mesh that is in the sculpture room. If you want to use the standard mesh that is in the retuple room, you have to send this retuple room mesh to the sculpture room. And if you have any sculpture working in the previous mesh, you could try using the reproject tool between the two meshes that are in the sculpture room. Every time you want to work with a standard retuple room, you will have to send it to sculpture room. There is no direct and real-time interactivity because there is no single mesh in the program. Here, the system is different. Let us understand. Regardless of the workflow, in this system I have several ways to accomplish my work, and I can also make several tools, features, and techniques in my favor. Here, the system is completely unified. As you can see, I'm going to get into the sculpt mode. I use Dynatop functionality that enables dynamic tessellation in the mesh. Dynatop would be equivalent to 3D code brushes, live clays, or brush with remove stretchings. This kind of system allows me to sculpt without worrying about the topology. Now, I'm going to start showing what we could do with the single mesh system and the unified system. At any point in my work, if I need to, I can enter edit mode, which is equivalent to the 3D code retuple room. Therefore, I can make any selection of polygons, features, and models to directly in the mesh. In this mesh, I'm going to modify the structure of it, and I know that everything I'm doing with this mesh, in real time I'd be directly affecting the mesh. Why did I say this if it's something so obvious? As I've said before, this is not possible with 3D Code because there are two different types of mesh, one in the retope room and the other in the sculpt room. So I've been able to sculpt and model directly in the same mesh. What else could we do? If I need to, at this time I can make the opening of the UVs. Yes, that's right. I can either temporarily make quick UVs for some particular technique, as well as I can do final UVs for the mesh. I believe that our artist knows the benefits this can bring to their work in relation to work techniques. With the opening of the UVs, I can, for example, at this time, enter in the texture paint mode. Now, the system is giving me the chance to creation of texture maps. I can paint in real time the different types of texture maps for my mesh like displacement map, bump map, normal map, diffuse or albedo map, and other types of maps that I want to create and paint. Here in texture paint mode, I have the possibility to perform the work similar to what exists in 3D Code. There is per pixel painting, micro vertex painting, and also the vertex painting of the paint room. I cannot forget to tell you that in this program it can also be done at any time the bake procedure. So far, we have done the same mesh operations in all rooms or modes of the programs like we enter in sculpt mode to sculpt, we enter into add mode for model and UV open, and we enter into texture paint mode for creating and painting texture maps. All this without having to make the slightest effort. Did you notice how practical, quick, easy and intuitive everything was? I had no problem, no confusion, and without complications. At any time I have complete control over any stage of my work, because any kind of change is made directly in this mesh and in real time. I believe that in this moment, you begin to realize the benefits that this system of single mesh would be providing, and not stop there. Please let me show you much more. With the help of this square, let's talk a little bit about something important, and what the great majority of artists know is the meshing quads. When you think of quads, quickly comes into the head of anyone who knows the multi-resolution system. Multi-resolution is a system that creates smooth surface through the subdivision of the mesh surface by the Cartman-Clark method and the simple method that maintains the current shape and also subdivides the edges. But we could use both methods in our favor. First, use the simple method to maintain volume, and after use Cartman-Clark to start the process of sculpting. The great differential of multi-resolution is to provide users with different levels of subdivisions that remembers changes made from one level to another. You can move up and down the levels of subdivisions freely and at any time. Changes made at low levels will be propagated to high levels, and details made at high levels will be maintained when the user goes down to the lowest levels. This type of system is widely used to generate displacement map, bump maps, and normal maps. Besides the benefits I just mentioned, in Sculpture, the multi-resolution system, due to its calculation in the subdivision of the mesh, causes the system to provide the high quality of brush deformation on the mesh and excellent fine and sharp detail in the surface of the mesh. The negative point of the system is that the mesh becomes stretched if the artist exaggerates in the deformation of the mesh, but in Blender, the multi-resolution allows users to solve problems and just to benefit from other things. Now, let's see in practice what exactly we can accomplish. At this time, we know of the existence of two different types of systems for sculpture and modeling: dynamic tessellation and multi-resolution. We could work from the beginning with a production mesh that has good topology and UVs, as you can see in this base mesh. And we could also work from the beginning through dynamic tessellation, as in the case with this face. However, nothing prevents the user from measuring the good things of the two worlds. Therefore, the artist can start his dynamic tessellation process, and when he finishes, he can generate good topology mesh, reproject the details, and use multi-resolution to finish the sculpt, detail, and finish the work. Talking about generating a good topology mesh, let me quickly demonstrate the topology process in the system. In this case, I added a new plane object and I used the snap function. Now, I can enter edit mode and start working with all the tools and features to create the new topology over the face I've sculpted. Now, I'd like to show you other good things about the multi-resolution modifier that only the system is capable of doing. This is extremely powerful and I think it's very special in regards to the multi-resolution modifier, that any other modifier that is found after it in the order of the stack modifiers can be applied, and the multi-resolution will accept this new information that will be part of their levels of subdivision. This is not great. Another interesting thing is that the user does not need to get stuck in the same mesh topology. This means that at any time you can insert and modify the mesh topology, and you can create new geometries using the extrude tool, which will not break the operation of the multi-resolution modifier, as you can see. You may think that seeing this result in the mesh that it is all broken and full of problems. I thought so, but not really. The mesh shows only a few minor flaws that I just softened the area at each level of subdivision and everything is solved and smooth. That's fantastic. Just good things, don't you think? Again, I need to repeat something that's very important and powerful in using multi-resolution. See that this system allows me a completely free workflow with at any time when I'm sculpting, and I realized the need to make any kind of change in the mesh. I enter edit mode and I use any modeling tools like extrude, cuts, smooth, and other tools. After any change in the mesh, as you have seen previously, as soon as I enter in sculpt mode, the mesh apparently presents visual problems in the place I made the changes. But the solution is the easiest and simplest to do. I just need to go back to the lowest level in multi-resolution and use brush with smooth and smooth out any region that has problem. I will need to do the smoothing with brush on each level of subdivision until the highest level is reached, and the problem will be solved easily. You may also realize that at some point I enter edit mode and use proportional addition with variations of influence to move, rotate, or resize the polygons in a fast and global way throughout the mesh. These changes will be accepted normally and without any problems in sculpt mode. There is no problem whatsoever, and the brush deforms the surface of the mesh perfectly and with excellent quality. Now, I want to make a very important observation. All these modifications, the structure of the mesh through edit mode with the modeling tools, nothing in the project is broken. If by chance the mesh has UVs and I change the structure of this mesh, as you can see, these changes are automatically propagated to the UVs. The only thing the user has to be aware of is when adding new geometry through the extrude tool. These new generated geometries will be located above the others in the UVs. To solve this problem, the user will have two choices that are quickly to make. The first is to just use the unwrap command for the entire mesh again. And the second is just select the area that the UVs are in trouble, and only this area perform the unwrap process. Again, I would like to repeat another important and special feature that multi-resolution allows the user to do. I can add any modifiers after the multi-resolution and apply the result within the multi-resolution levels. In this example, I added the displace modifier, and I take advantage of my model having UVs to add a procedural texture throughout the model. After configuring the appearance of the texture and strength of displace in the model, I applied the displace modifier because I did not need it at the time of a non-destructive process. I simply wanted to continue with my work that way, just because the system allows me to do that. This means that the information in the displace modifier will now form a definitive part of all levels of subdivision of the multi-resolution. I believe this does not exist in any other program. Completely fantastic and powerful. With this system, the user can perform different types of selections of polygons, vertices, and edges. This is important because from these selections, the user has access to fantastic features that make the difference while working. Thus, the first feature would be related to the selection of polygons. This would allow the creation of vertex groups and something similar to the face groups of the Mesh Mix program. With vertex groups, the user could create groups of polygons, vertices, and edges that would be used to influence a certain part of the mesh, would allow modeling, as well as a quick way of selecting and interacting with the mesh, allowing functions to hide and visualize parts of the mesh that the user would be working through shortcut keys, and also in the creation of masks or freezes. A differential that the vertex groups have is that the user can define influence of weights for these vertices, providing smoothing between the transitions areas of the vertices during the deformation. And other important functionalities would be realized from these vertex groups. For the vertex groups and mesh topology, the topological influence of brush and for other tools like pose and transformer could be realized. This means that only a certain area could be selected and deformed, and not the entire region around the brush or tools. Another good thing is that the user could use these vertex groups as a way of positioning in the scene instances of the same object or different objects with UVs or not. The second functionality would be extremely useful and very important that would provide a great differential for the users who would have at his disposal the system of modifiers. Each modifier has its particular effect on the generation and creation of geometries, deformations in the mesh, and restructuring of the mesh structure. Modifiers have as their main characteristic a non-destructive process of the mesh and everything is carried out in real time. Therefore, the system would allow the user to choose different types of modifiers that would be stacked in order. And the stack order of the modifiers would directly influence the final result of the mesh appearance. One important thing about modifiers is that they become even more powerful by accepting the vertex groups. In this way, they can deform or influence on a certain part of the mesh. Now, briefly, I will show you most of the modifiers so you have a little idea of the power of this kind of non-destructive process. Now, I would like to demonstrate a simple example with the use of modifiers. You may notice in this example of the orangutan the use of some modifiers in a completely non-destructive process, and that any necessary modifications can be made easily. Let's quickly see the process that was done in this example. Firstly, I used the multi-resolution modifier in a simple base mesh for the sculpting process at subdivision levels. Then, I used modifiers for mesh deformations like mesh deform, Laplacian deform, lattice, and simple deform. All of these modifiers deform specific parts of the mesh with the exception of the lattice and simple deform modifiers, which I used for the complete deformation of the mesh. This gives me complete control of this work. I may have overstated the use of some modifiers, but I intend to demonstrate to all of you what I have at my disposal in performing my work. You may note that I used two mesh deformers, one of each side of the face of the orangutan, to individually modify the shape of each side separately. As I move, rotate, and resize this structure, the mesh is deformed. The use of the Laplacian deform allows me to move specific parts of the orangutan's face similar to a facial rig. I created and defined on a few axes for a simple demonstration. You will realize that as I use the axis, I can have control of the deformation of the axis polygon area. Then I use the lattice modifier that helps me make general or global changes to the orangutan's format, as you can see as I change the lattice grid. The last deformation modifier I used was the simple deform that helped me make an orangutan movement effect. The next step of the orangutan is the fine detailing. I used the subdivision modifier which is the same as the multi-resolution, but without the subdivisions levels. My goal is to exclusively have more polygons in the mesh so it can work. Now, I've used 3 displace modifiers that aim to physically detail the mesh. The first 2 displace modifiers I have used procedural textures generated automatically, and that can be configured at any time. They are only the first basic layers of detailing. The last displace modifier has a special feature. I created and manually painted a texture map that has the most fine detailing. This map has been inserted in the displace modifier. The union of all these displace modifiers enabled me to have this final quality of the orangutan. The result could have been better, but for demonstration I think it's fine. This was a simple example demonstrating the power of the modifiers, and it's also important to note that the order of the modifiers influenced the final appearance of the mesh. I would like to demonstrate 2 mesh building structures that deserve to be highlighted in the system. The first is the metaball system, which is a powerful system of creating mesh by a non-destructive process. Metaball are objects created from mathematical formulas calculated in real time that have characteristics that simulate a mercurial fluid. When 2 metaball objects are close to each other and according to the area of influence, they attract and begin to merge. Metaballs can have 2 Boolean operations, addition and subtraction, that can be changed at any time. The metaball system is non-destructive. This means that each metaball object can be manipulated individually at any time through the transform operations, move, scale, and rotation. The metaball resolution setting can also be changed at any time. It would be great to have this in 3D code. Second is the skin modifier. I left to talk about this modifier just now because it has another functionality built into it that I will speak in a moment. Skin modifier is very similar to the 3D Coat Curves tool, but has special features. The skin modifier has features for creating a mesh in quads, and at some intersections, triangles may appear. The skin modifier for the use of vertices and edges can create a mesh topology in real time according to the position of the vertices. There is a very powerful feature. After the user finishes creating the mesh, the user has the option of creating an armature. This means that the user can pose the mesh through an automated system of bonds and weight influence in the mesh. It's a basic rig system created with FK and IK systems. This is wonderful. I know, people may think I'm exaggerating about rig and skinning, but this kind of single mesh system and a unified system could provide any kind of implementation. I would like to show an extreme example of freedom that the artist would have in his creative process. Maybe this could be considered the character design process. I don't know, but in this case, I'm much more interested and focused on demonstrating the use of any tool and functionality that exists in the program in my favor in a single mesh than any correct type of workflow. The main conclusion you all may have is that if I can accomplish this all in a single mesh without any kind of problem, so logically you can perform any type of workflow that is desired and correct for the performance of your work. Let's start. From a sphere, I sculpted this face through dynamic tessellation. Then, I went into edit mode and through the selection of polygons and modeling tools, I modeled that crest, a connector, and a wire. But why did I do it? Simple, because I could. Because the program allows me to do it. So, still in edit mode, I decided to open UVs for this mesh. That way I could create a texture map to deform the mesh through the displacement modifier, and at the same time I could have created a diffuse texture map to paint, and test the character's look depth if I wanted to. I decided to apply the displacement modifier with the information in this texture map that I created, only because I was satisfied with the result and so the mesh was physically deformed. In this same mesh, I decided not to do the pre-topology process, and I went through my work to see how far that system could take me or support my work. So, I added the multi-resolution modifier. To my surprise, even with a poor topology, the multi-resolution system behaved perfectly on the first level of subdivision, and I was able to sculpt perfectly and seamlessly through the mesh. I confess that at this point, I really enjoyed working with the mesh because the deformation of the brush on the surface of the mesh had a great quality. So, I thought about separating my detailing process from the sculpture, but with a great advantage of being able to apply that detail to the mesh surface anytime I want through the displacement modifier. So, I took advantage of the UVs that my mesh has, and I created a new texture map. I entered in texture paint mode, and in real time I started painting the displacement map in much the same way as 3D codes per pixel painting or micro vertex painting. With the detailing map done, I went back to the sculpture, increased the subdivision, and I began to unify and further detail the sculpture. In the second level of subdivision, I was able to sculpt extremely sharp and quality details. I confess that I felt a great difference in the quality of my work. After I finished, I added the displacement modifier and I loaded the detailing map that was previously painted. As you can see, I have a non-destructible process, and at any time I can paint and adjust the detail map separately from the sculpture. The last step was to deform on the character's face by taking advantage of the modifiers. Was it necessary to do this? I do not know, but once again the system allows me, and I was able to test. Why not explore the possibilities, right? For this, I first used and created vertex groups. Then, I added another modifier called Simple Deform, and I configured the modifier so that only the vertex of the vertex groups could influence and deform the part I wanted, which in this case was just the face. At the end of all this so far, what does this mean? For me, complete control and freedom to do everything I want, and I need in realization of the project. Now that you know my suggestion of unify the system under a single mesh, you can reflect fairly whether or not this is good for 3D code to become better. Everything I showed could be done the same in 3D code. The answer will be the fair consciousness of each of you, as I said. I see 3D code with enormous potential. In all my sincerity and honesty, I think that with all the potential that 3D code has, and in conjunction with the unified system and a single mesh, would be a major turnaround in the industry in favor of 3D code, because most of the artists always will have the expectation of working with this type of system in their daily lives. Maybe some users do not agree. That's okay with me. Each one has a different taste, and if they prefer something like the current 3D code system, well, it's the choice. And I respect everyone's preference, just as I'd like you to respect mine. You may have noticed that the system only provides benefits because it's so simplified, versatile, fast, and easy to use. All different types of workflows are possible to be made because the user would have in their hands all the features and functionalities of the entire program in their favor directly into a single mesh. With this kind of system, extraordinarily powerful features could be implemented like how I've demonstrated in the video and many others. I just scratched the surface, because the most important of all is to demonstrate a unified system and a single mesh. So, I leave this reflection to Andrew, the developers, and all of you. Thank you, and I will see you next time.